Hello everyone, I'm John H. Simacon under the program Master of Information Systems. Today we're going to discuss the discussion number 3, what are parallel systems? Provide illustrations to help your case. Differentiate them from distributed and network systems. So let's first define what is a parallel systems. In simplest form, parallel computing is the simultaneous use of multiple computer resources to solve a computation problem. Allows several processors to execute instructions in parallel or at the same time. Parallel or multiprocessor systems are designed for program execution speedup and fault tolerance. A problem is broken into discrete parts that can be solved concurrently. Each part is further broken down to a series of instructions. Instructions from each part execute simultaneously on different processors. An overall control or coordination mechanism is employed. So virtually, all stand-alone computers today are parallel from a hardware perspective. So say for example, in our picture here or in our image here, is a motherboard with ASUS that has Intel chipsets. It has higher cache bus to frequently directly accelerated system performance. Cache memory is usually tied directly to the CPU and is used to cache instructions that are frequently accessed by the processes that are currently running. So cache bus links all the essential CPU areas together. So higher cache memory frequency boosts PC performance. So here in this chart or in our table are the mostly well-known vendors for parallel computers. So why use parallel system or computing? The real world is massively parallel. In the natural world, many complex interrelated events are happening at the same time, yet within a temporal sequence. Compared to serial computer, parallel computing is much better suited for modeling, simulating and understanding complex real-world phenomena. So say for example here, so we cannot imagine modeling this galaxy information, planetary movements, climate change, weather, plate tectonics, rush hour traffic, auto assembly, jet construction, drive-through lunch using serial computing, right? So why use parallel system computing? So here are some reasons. Save time and or money. Solve larger or more complex problems. Many problems are so large and are complex that it's impractical or impossible to solve them with on a single computer, just like what we have discussed in the previous slide. Provide concurrency. A single compute resource can only do one thing at a time. So multiple compute resources can do many things simultaneously, right? Alright, so now let's discuss what is a distributed system. A distributed system is a collection of independent computers that appears to it as a single coherent system or a single system. So one example of a distributed system is the most popular internet. The internet. So the internet So the internet, for example, the net of nets, global access to everybody. Data, service, actor, open-ended or enormous size, no single authority, and etc. So say for example in our Google Drive, you are going to upload 5 gigabytes of photos into your drive. So it is very impossible to upload it in a single point of storage or server since there are thousands to millions of users access in one time on a single time. So in distributed computing, several servers, for example, in different countries are deployed and its mission is to save or upload your file. Okay? So by the way, distributed systems run on underlying computer network. For example, distributed file system runs on a network of computers. So here is the difference between the distributed and the network system. A network system is a system wherein multiple independent computers are connected by a network for communication and resource sharing. Here are my resources. Thank you very much and good day.